This is the second video for lesson 8.1. So this part is about unsaturated hydrocarbons. A saturated hydrocarbon is holding as many hydrogens as possible. And the only way it can do that is if all the bonds between carbons are single bonds, meaning then that all the rest of the bonds have to be hydrogens. That gives it the largest number of hydrogens. But an unsaturated hydrocarbon, there are some carbon-to-carbon bonds that are double or triple bonds, and those are called multiple bonds. And so we're going to look at situations where it's not saturated with hydrogens. There's less than there would be if it was an alkane. So we're going to start with the simplest unsaturated hydrocarbon, and we're going to deal with Eth. Now, what does Eth stand for? It's methyl ethyl. So meth-eth. So eth is for two carbons. So we're going to draw an alkane first. Now look at the lettering here. A-N-E, E-N-E, Y-N-E. This means it's a single bond, so I'll just put a line. E-N-E means there's a double bond involved. Y-N-E means there's a triple bond involved. So ethane will look like this. A single bond, and then there'll be hydrogens there to make 4 bonds total, and hydrogens here to make 4 bonds total. What is that going to look like? It's going to look like this. All single bonds. It's a saturated molecule, holding as many hydrogens as it can. The condensed structural formula will be like this: CH3, CH3. The molecular formula will be C2H6. Double this and add 2, and you get your 6. That's alkanes. Now let's do a unsaturated. Ethene, notice it's still 2, but there's going to be a double bond between them. Now that takes 2 of the bonds necessary for each carbon. So each carbon only needs 2 hydrogens, like that. What's that going to look like? Like this. So there are less hydrogens, so it's unsaturated. The condensed structural formula will be CH2, double bond, CH2. And then the molecular formula will be C2H4. Now let's look at one with a triple bond. It's called an alkyne. And specifically for this one, it'll be ethyne. So it'll be 2 carbons connected with a triple bond. Now that takes care of 3 of the 4 they need. So each one only needs 1 more hydrogen, like that. What will that look like? Like this. This is ethyne. They all start with the same root for the number 2. What will the condensed structural formula be? It'd be CH, triple bond, CH. Formula, C2H2. Okay, so this is the simplest form of each of these, alkane, alkene, and alkyne, for anything that'll have a double bond or a triple bond. Let's look at the general formula for each of these. This we've already dealt with. So you take your number of carbons for an alkane, for saturated hydrocarbons, you double it and add 2. That plus 2 takes care of the H3s at the end of any molecules, like that. Alkenes is going to be the number of carbons times 2, and that's the number of hydrogens. Now, the other type That's CnH2n is also, we just talked about it in the last video. So what type of alkane also has this formula? Go ahead and write this in. A cycloalkane has this general formula. Alkynes, if there's a triple bond involved, you take your carbons, double them, and subtract 2. So if I tell you there's, let's say 10 carbons, double it, that's 20, and subtract 2, that's 18. So it's 10 C10H18 for an alkyne. So let's do some examples of naming a formula or writing a formula if I give you the name. So here's our first one. Let's see. What do you have to start with? Count the carbons. 1, 2, 3, 4, 5, 6. 1, 2. Okay, so 6. What's the root for 6? Hex. Now look across. Are they all single bonds? No, there is a double bond, so that makes it an alkene. So it's hexene. Ene means there's a double bond in there somewhere. We're dealing with just adding one additional double bond or single or a triple bond. So we're not going to get into ones where there's more than one multiple bond added to it. Let's look at this one. 1, 2, 3, 4, 5. What's the stem root for 5? Well, that's pent. It contains a triple bond, so that's YNE. That's pentyne. That's one of the things I expect you to be able to do is look at a formula like that and name it. Now, let's go ahead and give you a name and you write the formula. This takes a little more, but oct is the stem right there for the number. So how many carbons do we make? Well, oct is 8. So I'm going to do carbons. 1, 2, 3, 4, 5, 6, 7. I'll put the 8th one over here. There we go. There's our 8 carbons. Now, ENE, what type of bond is that? It's a multiple bond. ENE stands for what? Double bond. Now, I can pick any location here and put that double bond anywhere. So you could try it, but I'm going to put mine right here. Now, everything else is going to be a single bond. So I'm going to put single bonds here. And now we need to go back and put hydrogens in. Well, here's the end. Ends always get a CH3 as long as it's attached to a single bond. Here's a single bond, so this is a CH3. Now, let's work our way across. These 2 bonds already take care of that, so I just need to put 2 more bonds with hydrogen, so CH2. Anything along the way is a CH2, as long as it's attached to another single bond. Now, right here, I've got to consider this has 1 bond already, and it has 2 bonds, so it only has 1 more available bond, so this is going to get just 1 hydrogen. It's going to be a CH. Here, I've already got 2 bonds and another bond, so this also only needs 1 more. So this is the setup that you would do for octene. Okay, look at this one, heptyne. First of all, what is hept? Do you remember? Hept is for 7. So I'm going to put 7 carbons. 1, 2, 3, 4, 5, 6, 7. Okay. YNE means what type of bond is additional in there besides single bonds? It's going to be a triple bond. So I'm going to, well, let's pick this location right here. 1, 2, 3. Now that means everything else is going to be a single bond. And now let's put our hydrogens in. Well, notice what's happening here. This carbon already has 4. 1, 2, 3, 4. It doesn't have any H. It won't. So if you see something attached to a triple bond, it's not going to need an H unless it's the very end one. Okay, so this is an end with a single bond, so that's CH3. This has 2, it needs 2 more, so CH2. That's taken care of. Now what about this one? Okay, 1, 2, 3, 4. This doesn't get any hydrogen because it's got its 4 bonds. Now this one has 2, so it gets 2 more. This has 2, it gets 2 more. And the ends, if it's attached to a single bond, is CH3. Okay, well, that is our lesson for week 8, day number 1. And now there is a quiz that you're going to take. So you're allowed to use your notes and the videos if you'd like to look at those while you take the quiz.